Okay. Gavin was asking about this one here, and I said second derivative. So let's go ahead and find the second derivative by doing what first?
In the first derivative.
All right, yep, Gavin's right about that. And so to find the first derivative, we have 1/3, and then we have 2x minus 1 to the negative 2/3. Is that right? Times what else? What else do we have to multiply by? The derivative of the inside, right? And so what we have here is we have 2/3, 2x minus 1 to the negative 2/3. So that's the first derivative. What's next?
One more derivative.
One more derivative. That's right. Gavin's been paying attention in class.
Trying.
Yeah, it's not the easiest thing to do, is it? Sometimes. Okay, then we have 2x minus 1 to the power of?
Negative 4. Oh, 6. 5.
Negative 5/3. Okay, good job. You guys over there, Hannah and Gavin, doing some heavy lifting. Times what? Times 2 again. Okay. So we go ahead and work all this up. We got, looks like in the numerator, we got negative 8. And down in the denominator, we got 9. And then we have this thing right here, the third root of 2x minus 1 to the 5th power, right? Or that's to the 5th power. Now, if we set this equal to 0, can this be equal to 0 here?
No.
No, so what can we do now? Set our denominator equal to 0. So if we set this denominator equal to 0, what can we boil this down to? Do we have to worry about the 9, the cube root, the 5th? No, we don't have to. Oh, it's going to be 0 if and only if 2x minus 1 is equal to 0, right? So x is equal to 1/2. And so now can we draw our number line?
C.
Yeah, so draw our number line, and 1/2, and then we put g double prime above here and g below. And so to the left of 1/2, is this thing going to be positive or negative? If we have a smaller number than, say, negative than 1/2, if we have 0, right?
Yes.
Then we would have a negative divided by negative, so positive. And then bigger than 1/2, we would have negative divided by positive, so we'd have this. So where's the function concave down? It's concave down on 1/2 to infinity because g double prime
Less
than 0. And there's a point of inflection. What is our point of inflection? So if we go ahead and find our point of inflection, POI 1/2, and what's our x value? If we plug in 1/2, what do we get?
0.
0. And that's our point of inflection. Doesn't say y, or what, but that is our point of inflection, 1/2 comma 0. So that's it.
Fun.
Fun, if you want to call it that. Okay. Okay, I want you to do another one that might be a little less. Anybody get that one right?
I got, yes, I didn't get the point of inflection, but yeah. I got
You didn't get the total point inflection, but you got,
I forgot the point of inflection.
you forgot that. Here, the thing about it is, I'll tell you what I've noticed on these things, that it's, sometimes you do all this kind of work and you forget everything that you're supposed to be looking for. So after you do the end, especially with these ones, where you have these steps, some of them will be long, just go back and look at what's being asked again. Take one last look to make sure you've answered or tried to answer what it was. Okay, now go ahead and do this problem 4. You should be able to do that one. I think this one is actually a little easier than problem 3.
Because there's none of those goofy, like,
Yeah,
fractions.
yeah, this is a straight up polynomial, so should be easier.
This is way easier than the.
Yeah, because you'll have the fractions and so forth.
Still
Aaron's
gotta
right.
find the point of inflection.
Aaron's right about that.
Is something funny, Hannah?
I think I need to get a quiz together for this.
No.
I think a quiz on this thing would be really good for tomorrow.
I think that's
Oh,
a genius idea.
Yeah. When Hannah does that, it even makes me want to do it more.
Yes, quiz.
It's like the briar patch. Hannah, it's because I don't want to leave a child left behind. No child left behind.
Yeah,
I
Hannah.
love thinking
I want all the
that
children to
people
learn.
what's wrong. Really just makes me want to go.
Oh, I didn't even need to find that. Oh, I see.
But Hannah, I'll tell you, if I do have one on a quiz tomorrow that's like this one,
I'm exempt from it.
no, this one here is a go. Problem number 3, not so much.
I guess that's better.
Problem,
I feel as though I've done this wrong.
even though problem 3 should be fair game, you should be able to do problem 3 or one like it.
No, not for a game for me.
I forget how to find the slope of stuff.
Yeah, that's why we gotta go ahead and cycle through this, spiral through thing.
I did it wrong. I need help.
Okay,
Okay, second derivative, right?
Mm-hmm.
Set that second derivative equal to 0. You'll find your critical numbers.
Mm-hmm.
Do your number line analysis. Do the.
So I'm doing it right. I'm just thinking
Yeah.
I'm wrong.
But what happens after you do that, you have to go and get what a tangent line is, and so you have to keep in mind what it is that,
I hate this.
do you hate the tangent lines?
I remember.
I just, yeah.
So what it is, it's asking you to go back and put together a tangent line problem in conjunction with a point of inflection.
Okay. Okay, so I think I got it.
Let me just go around.
I think I got it.
Think you got it? Who else thinks they got it besides, who
I
else
got-
is close to it?
There's 6x.
I'm close to it,
6.
yeah.
Yes.
No way.
It's the second derivative, actually.
I got the
I think,
second derivative.
I think.
All right,
Can we
good
go over
job.
it? I'm confusing myself.
Let me give you another minute or so, then
Okay.
we'll go over this thing. What about you, Hannah? Are you getting any place on this thing?
Oh, hey, Hannah. Go
X equals
Hannah.
-1, so that's your point of inflection?
That's the x coordinate of the point of inflection.
Very good, so now you know what to do with that X coordinate, right? Go back
You slap it
and
into the
fill
line.
in, yep. So, very good. What about you, Carson? Did you figure all this out?
So like the first one,
Almost.
y equals negative 1 is power. Okay, just making sure.
Okay, class, what I'm gonna do is I'm gonna work this out, and since you've all been working on this, you're in a position to correct me if I'm wrong, right?
Aaron is
Well, you too. You can correct me if I'm wrong too.
Hannah's
to a certain point.
To a certain point, yeah. That's what, so that's right. So what we have is we have y prime is equal to 3x squared plus 6x, and then y double prime is equal to 6x plus 6, is that right? And we set that equal to 0. 6 times
I don't like that.
x plus 1, is that right?
Mm-hmm.
So 0 equals x plus 1, so our critical number is going to be x equals negative 1, is that right?
Yes.
Okay,
I
good.
think we're doing that.
So, is that okay?
That's good.
Okay, then we go ahead and take this thing right here, and we say negative 1, and we go here to y prime and y, right? And then to the left of that, let's see, would be like negative 2. That's going to be negative, right?
Yes.
So we'll go like this, and bigger than like 0 would be positive, so we'd be like this. So we have point of inflection at x equals negative 1, right? Next, what do we need to find? We need to find a what and a what? I've been telling you, Gavin, you've been good at this usually. Point and a slope, right?
Think about that later.
So negative 1 is going to be your coordinate. And so if we plug in negative 1, we're going to get negative 1 plus 3 plus 2, right?
Yep.
Which is that 4?
Yes, that's what I'm thinking so
So
far.
4, and what else we have to do to find our slope?
You gotta slap negative 1 into the first group.
So plug negative 1 in here, so we're going to get 3 minus 6, right?
Yes.
Yeah.
Equals negative 3.
Oh, yes.
Yes, I did it.
I did it.
So we
I don't know, I
have,
doubted myself.
so we have y minus 4 equals negative 3
That's Gavin's.
x plus 1.
Who said it?
Is that right?
Yes, that's right.
That's
Is there-
supposed to be Gavin's job.
That's right, Gavin?
Yes.
Erase it and let him do it.
All right,
Yeah, erase it and took it.
okay. Any questions on this?
No.
See, this is not so bad, is it?
No.
Hannah's looking at it. Hannah's giving it the evil eye.
We didn't have to do this.
But you see, you have to kind of put some different things together from what we've been doing for a while now.
I had to actually think.
Yeah, and actually think and kind of cycle through.
Oh,
So, that was from prior years.
I hate having.
Okay, we are now to note card 30, which is our second derivative test. Okay, this is used to determine if we have relative maximum minimum of the original function. And basically what it's saying, if you have f prime, like a critical number where f prime of something equals 0, that's a critical number, right? And the second derivative exists, then if f double prime is greater than 0, then at this critical number, that means f of c is a relative minimum. Does that make sense? Because if f of c is greater than 0, is that concave up or concave down?
Greater than
Is greater than 0 concave up, or if f double prime is greater than 0, is that concave up or concave down? That's concave up, right? So that means, because we have this shape and we have f prime equal to 0, that means it has to be a relative minimum. And conversely, for this one, it's going to have to be relative maximum if f double prime is less than 0. And then if f double prime equals 0, then the test fails. Then you use the first derivative test, which we went over recently. So that's what that is. So here we have a problem that, number one, it says if f has a critical number at x equals 2, and that isn't even enough information. We'll say not only critical number, it has to be where f prime, it has to be this kind of critical number. So let's assume we know it's this, because what other kind of critical number could there be?
Oh, like a, what do you call it? Like
Yeah, where f prime is undefined, right? So we're only interested, so we have to assume, in this case, that we're talking about, this is one, a critical number where f prime equals 0. So what can we conclude about this? Hint, it's going to be a relative maximum or relative minimum.
it's going to be a maximum. Or no, it's going to be a minimum because it's above 0.
Yes, yeah, so f double prime is greater than 0, and we have f prime equals 0 at that. So we have a relative, what was it, minimum at x equals 2, because f double prime of 2 is greater than 0, and f prime of 2 is equal to 0. All right, so that's our answer to that one.
I like it.
Okay, so this is one of these problems, when you see it, you should think about it, and it should be about a 30-second problem. Okay, here's a graph of f double prime below. What is happening at f of 1 if f prime of x equals 0 at x equals 1?
Oh, it's be a relative maximum since it's below.
So f double prime is less than 0, and f prime equals 0, so that's going to be a, what did you say, Aaron?
Maximum.
A maximum. Okay. Yes, we'll say relative max at x equals 1, because f double prime of 1 is less than 0, and f prime of 1 is equal to 0. Right? Are you okay there?
Yeah.
You gonna slide down on the floor or something like that? All right. Oh, okay. What I want to do is we're kind of going into the next section, which has to do with curve sketching. Let's go ahead and work this. I want you to go ahead and work out problem 1. And while you work on problem 1, I'm going to go and I have, something to hand out to you.
Like what? Some grades?
Not a quiz.
Oh, that'd be for tomorrow.
No.
That should do problem 1 here.
No.
Here we go, here's.
No.
Oh, new packet, yay.
Yes.
Yeah.
Oh.
So, such excitement.
Always. Thanks.
Oh, look at that, that was fun.
That was a thick one.
I'm seeing boxes, Mr. G. What's going on here?
Whoa.
Are we moving into some 3D stuff?
Whoa.
Optimization.
Optimization.
Good job,
We
G.
talked about
This
optimization,
gives
yeah.
me geometry.
Actually, we'll go through
Like
this
I
kind of
said.
fast. It'll go pretty quickly.
I'm sorry.
That's a scarier looking section than it really is, because we're not gonna spend a lot of time there anymore. Okay, have you worked this one out yet, Gavin?
No.
Number 1?
Not for the game.
All right.
He's putting a finger on the desk.
Ew.
Ow. Ice cream is such a... Just yogurt part, it's head hurt.
I like it.
I mean,
Line of crunchy snacks put a zesty zing on your tongue.
Cheetos.
It's kind of weird.
Question mark.
Icky. I hate myself.
Making it longer than
This will be, this kind of thing would be just a perfect quiz for tomorrow, something exact, just the same questions, but just a different function.
Why not? What's it like this?
That would be like a perfect quiz for tomorrow.
I think so.
Do I have to find the second derivative?
Yeah, you would, because you have to find what? You have to find D, concavity, and points of inflection. So that's how you know you need to find a second derivative, right?
Duh, Hannah.
Hey, this is...
Hey, Hannah, look, Hannah's being accountable for her education. I don't want to
Yeah.
have Hannah criticized over this.
Aaron,
Now, she,
I'm asking questions because I don't understand. That's what you do in school. You don't just go to
Yeah.
school to not ask questions. I do.
I do.
Can y'all shush and let me prove my point?
Your point has not been proven.
okay, Hannah, I'm 100% behind you in this right now.
Thank you. I got your tea.
There's another one. You missed one.
I did?
I know you got it.
Oh.
It's that one. It was on your leg.
I love how you put it on yours.
No. I didn't.
Hey, well, I got step A done.
Very good.
Find all critical numbers to be, and I have to find the closed numbers for X, Y, Z. And our closed number. Well, I went as far as I can.
Yeah, that was really
I prefer not to. Not this.
Yeah, me too.
well,
Okay, I'll
get the same
close
answer.
everything, so I can- We're both on the same page.
Yeah.
My tummy is fearful.
Oh, it like that. I remember now.
Whoa. You know, I just realized, we're all in the same class in second period.
And third.
And third. Since
Yeah.
second period.
And fourth.
Oh,
You know, this is the only class I take attention
This class here?
no.
Really?
Government.
Cows. That one online.
to. That was not
It literally was a test.
good. I know we
It didn't count. Gavin didn't think it was a test, so it's not a test.
All the answers.
Yeah, I got it. Just
Um, You should have taken physics. So
No.
It's so easy.
Mr. Griffin, it's so easy.
So easy.
We've had 3 papers due and we haven't had 1 test.
You haven't had one test.
Oh, and we've only had 3 papers.
We've had tests, but they're.
Okay.
And we're doing Latin and Greek again, so
So,
it's so easy. I don't study for it until like 5 minutes before, and I make up everything.
okay, determine all critical numbers. So for any critical numbers, f prime of x is equal to 6x squared minus 6x minus 12. So 0 is equal to 6 times x squared minus x minus 2, is that right? And so we have 0 is equal to, is it x minus 2, x plus 1? So x equals 2, x equals negative 1. So those are the critical numbers, is that right? Okay. And the next thing is finding the intervals we're increasing, decreasing. So we come over here and we put up our friend here, right? So here's our f prime, here's our f, and to the left is going to be negative, negative. So that's positive, right? And between negative 1 and 2, negative. How is this so easy to do? Why is this easy to do? Well, because what you have a quadratic, right? And the quadratic is going to look, and it's positive quadratic, so we know if we graph the quadratic, it's going to look like this, right? So we know we're going to have positive to the left, negative in the middle. These signs have these factors, these zeros have multiplicities of 1. So that's it. So f is increasing on what interval? Intervals. Negative infinity, negative 1, 2 to infinity. And because f prime is what? Because f prime is
It's greater than 0.
greater than 0, thank you ladies. And f prime is decreasing on what interval? Everywhere else, right? Negative 1 to 2, because f prime is less than 0. And next thing, we're saying relative local extrema. Okay, so that's going to be part B. Part C, we have relative, but we can do the pre-justification. We have relative max, and even without looking where it is, we know the reason already, because what? F prime changed from what? To have a relative maximum, F prime has to change from what?
Positive change.
Positive to negative. And then we can go here, look at the number line. Where does the thing change from positive to negative? At x equals negative 1, because blah, blah, blah. And then relative min at x equals 2, because f prime does what? Changes from negative to positive. So that's this part here. Next part, determine where the function is concave up, concave down. What do we have to have for that? F double prime is what? What is our F double prime here?
We're not doing number 2, are we? Because I'm not reading.
F double prime is what? Take F prime, what's F double prime?
Double prime, 12x minus 6.
So 12x minus 6. Set that equal to 0. So x is equal to what?
1/2.
Yeah, 1/2. And so now, we go to 1/2. We say, okay, this is going to be F double prime, this is F. What do we get for less than negative 1/2?
Was it negative 1?
It's going to be 1/2 actually. Thank you. So that's good.
Negative.
Yeah, we get negative, so concave down. And over here, we are concave up. And what things we're looking for. So concave up on one interval,
1/2.
on 1/2 infinity, because F double prime is greater than 0, and concave down,
What's up, Doug?
Do I look like keys in here?
I don't know,
How you want to get here?
Where you sit?
Right there.
F double prime is less than 0. And what does it say the last thing is? Point of inflection at x equals, so D, E, POI at x equals 1/2 because F double prime changes from negative to positive.
I did all that and then trying to think about it.
Did you do that?
You lucky snake, I'm like halfway through 2.
Okay, so really, that's that. So this would be a similar problem to this would be really good for a quiz tomorrow, is what I'm saying.
I don't even think I could study this.
Okay, so, who's my partner? No.
I'll give you an